Hello, this is the Generally Approachable Sudoku for the 3rd of March 2024. It is Sequence Brick by Philip Newman. Sequence Brick, sorry, I mispronounced that. It's Sequence Brick. And you can see here we have the digits 1 to 9 in a random order here. So that is why it's called a Sequence Brick. It breaks the sequence. Alright, so normal Sudoku rules apply. So place the digits 1 to 9 in every row, every column, and every 3x3 box. Killer cages. Digits in cages cannot repeat and must sum to the total given. So those digits, for example, sum to 7, those digits sum to 11, and so on for every other cage here. Those are all the rules. With that, let us just begin solving. Right. So I believe this was a puzzle. This puzzle's name comes from, it's like a play on the word sequence break, which is like one of the classic Sudokus that was set a few days ago was called Sequence Break. But now we have a bunch of bricks here. Alright, let's start with the small numbers first. 3 and 4 only have one way to, 3 and 4 only have one way to make them. The 3 must be 1 and 2, the 4 must be 1 and 3. This 2 resolves this, and this is also resolved because of the 1 here. We can probably do the same with other things as well, like the big numbers. Yes, 17 must be 8 and 9. 16 must be 7 and 9, and this 8 helps resolve everything. Whoa. Okay, well 15 without a 9 can only be made of 7 and 8, because 15 can only be made of 6 and 9 or 7 and 8, but 6 and 9 is not available, so this must be 7 and 8. Similarly, 1 here means that this can't be made of 1 and 4, they must be made of 2 and 3. Now, what else do we have? Maybe this 9 here. Yes, this 9 here can't be made of 1, 8, 2, 7, or 3, 6. So it must be made of 4 and 5. Which means now this digit, because those digits sum to 6, each constituent cell must contain a digit less than 6. This cell, therefore, cannot be 1, 3, 4, or 5. It must be 2. That cell is a 4. That probably gives us some stuff. Yeah, like those digits, for example. I mean, it's the same as this, right? Those digits can't be 2, 9, 3, 8, or 4, 7. They must therefore be 5 and 6. 4 in this box, because of those 4s here, must now be there. What else do we have? Honestly, we could probably do the same on the other side here, like this 14. Yes, okay, it's pretty hard to explain the 14 because 6 is a bit easier, the number is smaller. But 14 can be only made in one of two ways. It's either 5, 9 or 6, 8. This cell can't be a 9 or a 5, which means that this can't be made of 5 and 9 because that would have no digit, which means this must be made of 6 and 8. And actually, because of the 8 in one of those cells, we can resolve this. I can probably put a 6 in this box. Yes, I can. It must be here. I can probably start solving those digits as well. Yeah. Maybe. I'm not sure. I mean, this digit looks pretty constrained because it can't be 2, 3, 4, or 6. It must be 1 or 5 because it has to be less than 7. And 1, 5, flip over. Yep, this digit can't be 6 because, of this 6 here. So that digit can't be a 1, meaning it must be 5 with 2. This 5 resolves this 5, 6 pair. And the remaining digits are 1, 2, 3 in this box. This 2 must be placed here. This forms a 1, 3 pair. Now those digits are 1, 3, and 6, I believe. And we can probably eliminate 1 from those cells. So 1 goes here. This 3 resolves this final 3, 6 pair. Oh, it's not 1, 3, 6. Hold on. I'm so sorry. It's 1, 3, 7. I can't read sometimes. The entire logic is still the same though. 1 can't be in that cell, must be there. This 3 resolves them all. Yeah, I think I'm a little bit rusty in terms of Sudoku at this point. I haven't really done a lot of Sudoku streams while I'm here. This must be 6, 7, and 8. 8 come in those cells, so they must be up there. I've been focusing a lot more on just regular gaming instead, which may be an issue. This is 3 and 5, which do sum to 8, so we can confirm that. So this cell is technically not required, this cage, but I guess it's there because it's generally approachable. Alright, this must be 4, 8, and 9. And it's a bit hard to disambiguate, but it's fine. Alright, let's take a look at other things here. 4, 5. I mean, those digits form a triple. They have to be 7, 8, and 9. And actually, yes, because 8 coming in those cells, that resolves. Well, it doesn't resolve, it was an 8 here. This 7, 9 is still there. Is this resolvable? Yeah, it's probably the 13 cage, right? Because the 13 cage is either 4, 9, 5, 8 or 6, 7. The 6 here means it can be 6, 7. There are 2 4s here, so none of those cells can be 4. It can be 4, 9. It must therefore be 5 and 8. Whoa, 5 and 8. And this 7, 8 pair resolves this. This can be 8. So that also resolves this 4, 5 pair. So this digit now can't be 4 or 8. It must be 9. And that gives us some stuff. Like that's also a triple. Actually, that's a pair. Let's resolve that first. This is just 3 and 7. Yep. 3, 7. Those digits are 2, 3, and 4. 2 come in those cells. 2 goes here. This must be 4. That must be 3. Those digits are 7 and 5. 7 resolves that. And they do in fact sum to 12. Is this another X windmill? I think it is. Yeah. All of the rotationally symmetrical cells do sum to 10. Alright. Now, that's a triple. They have to be 1. Actually, this is a triple first. Let's figure that out. 1, 4, 9. Yeah, 9 come in those cells, so 9 goes up there. Can we resolve this? Not yet. That digit is either 1 or 3 though to finish the row, which is resolvable because of that 1. This is actually also a triple. It's a 1, 4, 1, 2, 4. So this can be 1. 3 resolves this, which means that this must now be 4. That resolves basically everything. That's a 3. 4 resolves this 4, 8 pair. And yes, 3 in the corner. Can't forget that. That's like the most important part of every puzzle. 1 must be here. Those digits are 6 and 9. Nice. I kind of hope that I would, you know, spend a bit more effort on Sudoku at this point, but schedules, you know, that's okay. This digit must not be 8. That's a triple. It has to be 6, 9, and 8. 8, 9 come here, so that's 6, which resolves everything else. This must be 8 to finish the row. 9 here means that's 7, so this is another triple. It has to be 4, 5, and 9. This can be 4 or 5, so that's 9. 4 here resolves the remaining pair. Those digits have to be 1 and... I blanked out. 1 and 9. Wow, okay. So 1 here means this has to be 9. Those digits are 2 and 6. 2 here resolves that. And we have finally a final triple, which are 1, 5, and 6. That's easy. 1 must be here. The 5 here means that is a 6, therefore this is a 5. Solving the puzzle in 7 minutes and 6 seconds. Great puzzle. Yeah, I hope you enjoyed this video. I'll see you guys next time. Bye bye.